Hello, my name is Timo Haimi from Metso, Metals Finland, and like I said, I'm here to talk about green iron smelting and the possibilities in Australia. And first, take a look what's Metso, then what's green iron, and what has Australia to do with this. And as many of you know, Metso, they have been participating here for a long time. It's a Finnish company, mining technology company, a lot of people working here, 5 billion company, and a lot of R&D actions and locations globally. But me and a couple of my colleagues here, we are from the metals business, which we are first time here in the IMARC conference here. Wanted to see what you, the mining guys, are doing. Our biggest business is otherwise in Metso is the minerals business and the aggregates business. But the metals business, where we are with the smelting guys, who we are, well, we have decades of history. And for example, this flash smelter, world's first flash smelter in 1949 in Finland for the sulfide copper ores. This is the great technology for copper production, nickel production, and we had tens of circular and rectangular smelting furnaces for different metals. And these are the main technologies here, different kind of electric smelters and for different purposes. And we have been usually making all other metals than iron. But iron has been our usually like a byproduct or even like impurity. Nobody has been that much interested about this molten metals. This iron, but at the moment this is like so much interest about this decarbonization, green iron, green steel technology. And first of all, to let you know that what is green iron and green steel, we are in the up left. You can see the blue columns. Those are the total emissions of the steel production globally. Those have been increasing for a long time, but now in recent years it has been stabilizing and maybe going down, which is good because the last column is the target where we need to go to fight the global warming, which means that the intensity, CO2 intensity of the steel production needs to be going down. And it means that we need to go to these zero emission steels or near zero emission steel. So International Energy Agency is having this definition, for example, that less than 400 kilos of CO2 per ton of steel without using scrap. And these kind of projects, in the bottom left, you can see that how many projects are going on. There's like active projects, like 15 million tons, but it's like 50 million tons of products are out there. But as we know, the projects, they are going more active and not so active phases depending on many situations. But it's not enough because we need, of course, like more than 100 million tons of this near zero steel projects to meet these CO2 emission targets for the iron and steel industry. And why the projects are going more active and not so active is mostly because of the prices. So there are these green steel prices compared to just the standard hot rolled coil. So you are seeing like a 100, 150, 200 euros premiums for the steel. Some companies can take that steel price differences like the automotive companies, but not all. And this is one topic of course for the projects. But these projects where they are located, in the left you can see the active green steel projects in Finland, in Europe, including Finland. It is unbelievable, but it's because we have this extra energy, CO2-free energy, and we have this Sweden, the best iron ore in the world. And you can also see that the European Union is funding all of these, all those best projects they are funding. So a lot of is happening in Europe. But the problem is that, not a problem, but the one interesting thing is that they are all based on DRI plus EAF technology, which you probably know. It is down here. There's a DR plant using direct grade pellets, and which means more than 67% iron. And then you have the arc furnace. With this technology, you can buy it already. It is proven. 130 million tons is per year is being produced by that route. You can get lower emissions there, but you need high-grade ore. And currently only a few percentages globally are this high-grade ore. But you know, you mining professionals, you know better that if you can do more beneficiation, then you get higher grade. And some of these you can upgrade, but a majority of the global ores are still staying in that blast furnace grade, which is the red bar there. That's destined to be going to blast furnace, destined to be used carbon, and the blast furnace decarbonization is challenging. You can put the carbon capture and hydrogen and everything, but still you end up in 1,500 kilos emissions. So that's very difficult, that red bar. So you need like a new solution for that. And if you look at Australia, you know that the Pilbara area, like Greg Garlick and the Newcastle University PhD guys here saying that this is well suited for the blast furnace route, but it is very difficult to make the green iron unless you go with the smelter route, which is here in the bottom. There's stating that we have a high iron yield with the fluid bed and the DRI smelter route. So that's very promising. Of course, our minerals colleagues are like, hey, come on, let's do more beneficiation. But I assume you know it much better than me that if you, in some point, you are doing more beneficiation, you are losing too much iron, which is not acceptable anymore, especially these Australian hematites. And then we come to the smelter, that this is maybe the better solution for these lower grade ores. Have this smelter and do this kind of a hot beneficiation. There we have raw material handling, blast furnace grade iron ore, direct reduction plant, and then we have the smelter. This concept is for two smelter, totally 2.5 million tons of molten green iron. All the gang, what is coming from that ore, it's going to the backside to the slag product, which you can utilize. And then on the another side, you have a slag-free molten green iron product, which you can granulate, or if you have a steel plant next to it, so you can produce steel directly. But the smelter technology, what we are utilizing here, it's based on all the equipment, what we know. We are using the same equipment in all the other metals, all the other projects. We have the furnace structure from the flash smelter. We have electrode equipment to bring the electricity into and then we have cooling elements in the wall. We want to have the 10 years lifetime, same as with the blast furnace, continuous operation, gas cleaning, all of that. And one unit is like 1.2 million tons. So these kind of a standard units we need to make these commercial size plants. And this is like a perfect solution for replacing blast furnace together with the direct reduction plant. And the product which is coming out, it's perfect product for the steel making. All the steel makers, they are eager to get this CO2 molten metal or granulated metal into their arc furnaces or BUF. And to prove this, we have our existing pilot plants in Finland, in Pori Research Center, but they were too small. We operated and we decided that we need a new one, we need a bigger one. So last Friday, this new pilot plant in Finland was inaugurated. Down is the picture from the celebrations last week. And so now this is operating. Next week we will start heating up and start making the first test run. And now this is free for all customers to see what we can do with this. And the future expectation that where is this green iron and green steel production, where is this being done? Well, this is a big topic, of course, but first of all, you need to have the ore. In the high quality DR ore, like I said, that we have in Sweden, you have it in Brazil, and North America, okay, some in South Australia also has. So all of that is going to be used for the DR plant and the arc furnace projects, either with the natural gas or hydrogen. But then this other ores, well, you should be locating these hubs next to the ores or next to the shipment routes. And so that's one topic. And then the electrification, hydrogen production, electrification, where you can put this. You would need to have this infrastructure to be built, and so this is like a combination, like Middle East, for example, they have a port, a seaport, and then you have a natural gas, and also a lot of renewable potential there. But for example, Europe, these are the blast furnaces in Europe, they are all located on top of the coal reserves based on coal. And so that's not exactly very green. And also this Central Europe, if you think about, still they're using Russian natural gas. So not enough energy there to produce too much of hydrogen, for example. So therefore, these new steel making plants, or they might not be at the same locations where the blast furnaces are now. Because now if you look at like Australia's renewable possibilities, you have this the global wind atlas. You can see that there's good wind opportunities. Also in Finland we have, everybody has been doing using the bicycle to school, it's windy all the time. So it's very nice that now they are utilizing the wind, so we have extra power in Finland with the CO2-free power. But Australia has this good potential compared to many other locations. And solar is the same thing, you know it much better than me, huge opportunities here. So for us, when we are looking outside, it looks like a good opportunity for Australia. A summary, like I said, if you have a high quality ore, you go with the DR plant at the EAF, but if you have less than 65% iron, then better to use this kind of smelter intermediate step for hot beneficiation and get rid of the gangue, not losing the iron in the green iron production. Now a smelter, we can take fines or pellets, and fines is especially interesting for the Pilbara stuff, which is difficult to pelletize. And we can take the hot or cold material. Hot, of course, is better, so you are saving energy. HBI, we need to restrict. And hydrogen or natural gas, well, in the future, the project needs to be based on hydrogen, but the short term, we see that the natural gas is cheaper and more feasible, and it's also easier to smelt, so we would like to utilize, or usually the projects, they are utilizing the natural gas at the moment. And then the possibilities for the Australia, like I said, the target is to create like a new supply chain for these green metallics. And this is what these European steel plants, Japanese steel plants, who want to make this low CO2 steel, they cannot make all of this reduction work and DR by themselves. So they would like to get this kind of granulated green iron into their arc furnaces. And me running in the steel plant, buying the scrap, you don't never know what you're getting from the scrap suppliers. With these kind of granulated virgin iron units with the CO2 free, I mean, you have the constant analyze, so it's easy to use. So you would likely to get more premium out of this compared to the selling just the iron ore to markets. And so utilizing the iron ore mines, locations, shipment routes, renewable energy possibilities. Well, Australia workforce, okay, Pilbara, not so popular. Population density is not so much, but anyway, if you compare to some other completely desert areas, so this is much better situation. A stable political environment that we cannot say from all countries, and the impact of it is like huge if you look at the lower global CO2 emissions, and we are generating more value compared to the iron ore. But what's the profit for the miners? Because of course you have an operational cost of making hydrogen, making the smelting. So what is the end result? That is, you get different results every time you are calculating, and very difficult to do it yourself. So better to do it together. That you are the specialist with the mines and the iron ore. We can bring the input for this smelter step. So please contact us at our Metso booth in G13, and let's continue more detailed discussions there. Thank you.